Alrighty, well today we're moving into section 5.2. 5.2 is about normal distributions and using those normal distributions to find probabilities. So I'm going to be finding probabilities with the normal distribution. This is kind of a short section, so don't blink or you'll miss it. In section 5.1, we learned how to find the area under the normal curve. It turns out that we can use that same process to help us find probabilities. So here's an example. We have a normal distribution where the mean is 350 and the standard deviation is 20. Now let's assume we're looking for an x value of 359 as the value of the random variable. The graph would look something like this. Okay, so you can see the 350 is right in the middle because that's the mean. We have our 359 and then there's a shaded area to the left. What that shaded area represents is the probability that the value of the random variable is less than 359. The shaded area represents the probability that the value of the random variable is less than 359. So if we can figure out how to find that area, then we can compute the probability. Okay. In section 5.1, we learned how to take an x value and convert that x value to a z-score, then use our standard normal distribution table to find that z-score and get a table value, and how to use that table value to then compute the area to the left of that particular x value. So we have a fact here. And the fact is that when you convert a value of the random variable to a z-score, the area to the left of the random variable value on the normal curve is the same as the area to the left of the z-score on the standard normal curve. Oh boy, what does that mean? It means that no matter what normal distribution we're looking at, if we were to find the area to the left of our x value, the value of our random variable, if we then took that x value and converted it to a z-score and found the z-score value on the standard normal table, that the area to the left of the x value would be the same as the area to the left of the z-score. So let's take a look at that. Okay? So if we convert 359 to a z-score using our z-score formula, here's what we get. Z equals x minus mu over sigma. Remember, our x is 359, the mean was 350, and the sigma was 20. So this is 9 over 20, and 9 over 20 is 0.45. So that's our z-score. And what that little note says is that if we looked at the two graphs, the graph on the left is the graph of the normal distribution that we were just talking about, and the graph on the right is the standard normal distribution. Well, the area to the left of the 359 on that normal distribution is the same as the area to the left of z equals 0.45 on the standard normal distribution. And what that means for us is that we can use z-scores to help us compute probabilities, because we can take any x value, convert it to a z-score, use the standard normal table to find a table value for that particular z-score, and then either use that table value or 1 minus the table value to find the area. And that area is the same as the area on the original distribution. So we can find areas and therefore probabilities by looking at the standard normal distribution. So we've got an example. It's about emergency rooms. The average wait time at the local emergency room is 90 minutes, with a standard deviation of 25 minutes. A person enters the ER. Compute the following probabilities. So first, we want to know what's the probability that the wait time is less than 60 minutes. Next, what's the probability that the wait time is more than 2.5 hours? And the third thing is, what's the probability that the wait time is somewhere between 43 and 81 minutes? We're going to look at each one of those separately. let's start with the first one. Okay, wait time less than 60 minutes. So our x here is 60. So we're looking for the probability that x, the time, is less than 60. On the normal curve, this would be area to the left. Less than gives you area to the left. So we're going to take that 60 and we're going to convert it to a z-score. So when x is 60, z is going to equal 60 minus 90, because 90 was the average, over 25, because 25 was the standard deviation. 60 minus 90 is negative 30, so we get negative 30 over 25, and negative 30 over 25 is negative 1.20. Now, your calculator might tell you it's negative 1.2, and that's fine, but remember, we're going to use this z-score on the table, and when we use the z-score on the table, our z-scores have to have 2 decimal places. So that's why I put the 0 at the end. So if we look up the negative 1.20 on the standard normal table of values, you get 0.1151. And again, you need to be printing out your notes and have that standard normal distribution table in front of you when you're doing these kinds of problems. Everything in Chapter 5, you're going to need that to consult that table. Actually, everything in Chapter 6, too. So having a copy of that table with you is important. So that table value is 0.1151. Now what about, and that is the probability. So the table value is 0.1151. That means the area to the left is 0.1151. And that is also the probability. Because we saw back in section, in Chapter 4, that area was related to probability.
Let's take a look at part B. Here we're looking for the probability that x is greater than 150. On the normal curve, this would be the area to the right of 150. So we're going to use our z-score formula again. Z equals x minus mu over sigma. That's going to be 150 minus 90 over 25, which is 60 over 25, which is 2.40. Now if we look up 2.40 on the standard normal distribution table, we find out that there's a table value of 0.9918. But this is greater than probability, which means we're looking for area to the right, so we have to do 1 minus 0.9918, which is going to be 0.0082. Remember that area corresponds to probability, so the probability that the x value is greater than 150 is going to be the probability that the z is greater than 2.40, which is 0.0082.
The last of these 3 questions is a little bit more complicated, and the reason that it's a little bit more complicated is because you have to find 2 separate z-scores. Okay. We look at the 43 minutes and the 81 minutes, and we realize that we have to do some subtraction, right? We saw problems like this back in section 5.1. Now we see how this one's going to work here. So we're going to compute the area to the left of x equals 81, and then subtract the area to the left of x equals 43. Left of means the table value is the area that we're going to use. So we need the table value for when x is 81 and the table value for when x is 43. But to find those table values, we have to convert to z-scores. Remember we said that whenever you're converting to z-scores and you're doing area between, you should always start with the x value in the z-score that's farthest to the right. So for us, that would be 81. So we're going to use the z-score formula. Z equals x minus mu over sigma, which is going to be 81 minus 90 over 25, which is negative 9 over 25, which is negative 0.36. So that's my first z-score. Then I look at x equals 43. Same z-score formula. Z equals x minus mu over sigma. But now it's 43 minus 90 over 25, which is negative 47 over 25, which is negative 1.88. So we need to look up each one of these values on the standard normal distribution table. When z is negative 0.36, the table value is 0.3594. When the z-score is negative 1.88, the table value is 0.0301. So we need to subtract those two values. The probability that the x is between 43 and 81 is the probability that the z is between negative 1.88 and negative 0.36. And we're going to do this subtraction, 0.3594 minus 0.0301, and that's going to be 0.3293. That would be the probability that the wait time is between 43 and 81 minutes. So we've got a little note here. And basically what the note is it's telling you how do you compute the area and therefore how do you compute the probability for different situations. So when you're computing area or probability using z-scores, if you're trying to find area to the left, you're going to use the table value for the z-score as that area. If you're trying to find area to the right, you do 1 minus the table value for that z-score. And if you're trying to find area between, you're going to use the table value for the right z-score minus the table value for the left z-score. So it's right minus left when you're finding area between. Okay, so we've got a little practice problem. This one's about gasoline. The average cost for a gallon of gasoline at gas stations in the Central Valley is $3.84.9 per gallon, with a standard deviation of 25 cents per gallon. A gas station is chosen at random. Compute the following probabilities. Okay, remember if you ever buy gasoline, you notice that it's not just $2.83 a gallon, it's 2.839 per gallon, right? Because there's a 9/10 of a cent federal tax that goes on every gallon of gas, which is amazing. But instead of just doing 1 whole cent, you could raise a whole lot more money just with one extra cent. Alrighty, so we want to compute these following probabilities. What's the probability that the cost is less than 3.999 per gallon? What's the probability the cost is more than 4.059 per gallon? And what's the probability the cost is between 3.769 and 4.159 per gallon? So again, this is very much like the problem that we just did from the wait times at the hospital. So pause the video, and when you're ready to see the answers, just hit play. Okay, so let's take a look at our solutions. For part A, we're looking for the probability that the x value is less than 3.999. So less than, remember, is area to the left. So area to the left is exactly what we get from the table. So when we find this z-score, the table value will be our area, and therefore it will be our probability. So let's take that 3.99 and find the z-score. Z equals x minus mu over sigma. The x is 3.999. The mu is 3.849. And the sigma is 0.25. So when we subtract on top, we get 0.15 over 0.25, which is 0.60. And again, I went to 2 decimal places because our z-scores are 2 decimal z-scores on the standard normal distribution table. I'm going to take this z-score and find its table value. So the table value for this z-score of 0.60 is 0.7257. That's the area to the left. And since that's the area to the left, then if I'm finding the probability that x is less than 3.999, that's the probability that z is less than 0.60, which is this area, 0.7257. So that's the answer to part A. In part B, we're looking for the probability that x is bigger than 4.059. Well, a greater than probability gives me area to the right. So that means when I find my table value, it's not going to be the area. I'm going to have to do 1 minus the table value to find the area that I'm looking for, because table values are always area to the left. But we are going to still start with a 4.059 and find the z-score. So z is x minus mu over sigma, which is 4.059 minus 3.849 over 0.25. When we do the subtraction, we get 0.21 over 0.25. And 0.21 over 0.25 is 0.84. So that's the z-score that corresponds to an x value of 4.059. We're going to look this z-score of 0.84 up on the standard normal distribution table. We look for the row that's marked 0.8 and the column that's marked 0.04, and where those two meet is a table value of 0.7995. Because we're looking for area to the right, we have to subtract this 7995 value from 1. So the area is going to be 1 minus 0.7995, which is 0.2005. That area corresponds to the probability. So the probability that x is over 4.059 is the same as the probability that the z is more than 0.84, which is 0.2005. The last problem is the tricky one. It's the one that requires us to find two separate z-scores. So we're going to find the z-score for x equals 4.159 and the z-score for x equals 3.769. Remember, we always go with the right one first. So for the x equals 4.159, the z-score, x minus mu over sigma, is 4.159 minus 3.849 over 0.25, which is going to be 0.31 over 0.25, which is 1.24. For the second x value, x equals 3.769, the z-score formula doesn't change, but when we plug in the numbers, we get 3.769 minus 3.849 over 0.25. When we subtract, we get negative 0.08 divided by 0.25, which is negative 0.32. So we're going to start with our z-score of 1.24 and find the table value for that. So we look up 1.2 in the rows and 0.04 across the top, and the table value will be 0.8925. So for the second one, which is the z-score of negative 0.32, we're going to look up the row for negative 0.3 and the column for 0.02. And that's going to give us a table value of 0.3745. Now we have to subtract those two values to find the area and therefore the probability. So we take the 0.8925 minus the 0.3745, and that gives us 0.5180. So the probability that x is between 3.769 and 4.159 is the same as the probability that z falls between negative 0.32 and 1.24, which is going to be 0.5180. Okay, so that brings us to an end of section 5.2. So please look on Pearson for your homework, and have a nice day.